Hello everybody. Today we will discuss problem with a finite electric circuit. So before that, please subscribe if you want to get new problems every day. Thank you. Finite circuit chain. In the electrical circuit shown in the figure, the EMF of the source is 10 volts. The chain R2, R3 is repeated 17 times. First question. Find the current flowing through resistor R4, this one. If R1 equal R3 equal R4 equal 3 ohms and R2 equals 6 ohms. Question number 2. The analysis of complex electrical circuits can be simplified if the circuit section containing several sources and the resistors is replaced by one equivalent source with the EMF E and the internal resistance R. What equation source specify R internal and EMF can replace a section from A, E, and B, so it's connected to outside resistance. So can replace section A, E, B of the circuit shown in the figure. And the question number 3, in the circuit shown in the figure, now R1 equals 3 ohm, R2 equals 6 ohm, R3 equals 1 ohm, and R4 equals 17 ohm. Find the current through resistor R4 again. Solution. Question number 1. Find the current through resistor R4 if R1 equal R3 equal R4 equal 3 ohms and R2 equals 6 ohms. When we deal with circuits like this, where we have repeated chains, we have to find what kind of recursion we can use here. Let's try from the right side. Suppose that through resistor R going current I, unknown current I. So R4 equal 3 ohms and R3 equal 3 ohms. Together they equal 6 ohms. And also we have in parallel resistor R2 with the same 6 ohms. It means that if we have current here I, that will be same current through resistor R2 I. And both these chains, they have current 2I. And also if we count what is total resistance for this chain, that will be 3 ohm again as R4 before. So it means that we have the same situation as before, but now when we exclude this part, we have same chain but with the current 2I through this equivalent resistance. And we can repeat this procedure 17 times. So it means that each time we can replace next resistor with R4 and current will increase twice. So totally we can write this expression that after all total current through our EMF equal 2 power 17 unknown currents I. Let's draw the picture for this process. On this picture all currents are shown. So we have current I through R4 and here. After that we have current 2I here, etc. In the last we have current equal 2 power 17I. In total equation we have this current through resistor R1 and resistor R4. So that will be 3 ohm and 3 ohm. So that will be this ohm law, that current I0 equal EMF divided by series connection of R1 and half of R2 or R4, which is 3 ohm plus 3 ohm. So totally result is this one. That's the answer for the first question. Question number 2. The analysis of complex electrical circuits can be simplified if the circuit section containing several sources and resistors is replaced by one equivalent source with the EMF E and the internal resistance R internal. What equivalent sources specify R internal and E EMF can replace section A, E, and B? Let's mark it. This section we have to replace. So let's do this. First we can write equation for Ohm law for our equivalent EMF, our internal resistance, and the outside resistor. This is our series connection of our equivalent scheme with the outside resistor R. And now we can write Kirchhoff rules for this part of our scheme. So first we can write current through resistor R1, R3 and the outside resistor R. And the second we can do current through R1 and R2. So that will be these two equations. So one is current I0 through I1, and after that current I through resistor R3 and R, and second we have current I0 through R1 and current I0 minus I through R2. So we have two equations and we can exclude from them current I0. That will give us current I. So that's the expression for current I using these two formulas. And now we can compare this Ohm law with this Ohm law. Immediately we can see that EMF, this EMF could be counted as this expression, and this internal resistance like this expression. So now we have EMF, internal EMF equivalent. It's this expression, and the internal resistance is this expression. And this is the answer for the second question. Question number 3. In the circuit shown in the figure, R1 now equal 3 ohms, R2 equal 6 ohms, R3 equal 1 ohm, and R4 equal 17 ohm. Find the current through resistor R4 in this case. We can think that the second question was not just for fun. It was for a reason. And the reason is that we can use this knowledge from question 2 to apply it for analysis of our this circuit in the for that situation with this resistance. Let's try to count what happened with these resistors and these two equivalent EMF and internal resistance. So if we put numbers, we have these expressions. We can get for equivalent EMF 2/3 of initial EMF, and the internal resistance equal exactly R1 when we put all numbers here. So it means that we can repeat this operation 17 times, and we will get this last EMF, effective EMF, 2/3 power 17 from initial EMF, and we got the same internal resistance R1. And after that we can just apply this last results to the last connection with the resistance R4, and we will get this formula. R4 equal our last equivalent EMF divided by a series connection of R1 plus R4, which will give us this result. So this is the demonstration how to use straight recursion and with the equivalent EMF and internal resistance, and reverse recursion just using equivalent resistance. So that's it. This is the final question.